You are currently the only person in this conference.
Check, check. Good morning, everyone. Can you hear me? Okay. So, clear naman yung audio? Okay. So, thank you for your replies. So, yeah, for today, we will go to Module 2. I hope you already answered the prelim exam. I hope you already took that now. If you haven't pa, please send me a message so I can open. No? So, yeah. And I will check that prelim exam within the week. Okay, along with the uh, homeworks that are assigned to you now. So, okay, let us go now to our topic. Ayan, good morning, Erwin. Okay, morning pa lang. Sige. So, let's go now to our topic for today, which is fluid statics. Okay? Now, what do we mean when we say fluid statics? Well, they are fluid, either gas or liquid, that is in stationary position. Okay? That's what we meant when we say fluid statics. So we'll talk about fluids in containers that does not move. Okay? So this is the topic for today. This is what the discussion will revolve. Okay? Now this PowerPoint presentation was developed by my co-faculty, Engineer Adams Junicio. He's a structural engineer, and I'm just using this for this discussion, no. So I did not make a PowerPoint presentation anymore. We'll just study this one. Okay, so if we are ready to learn today, please type pressure in the chat box so we can see if you are ready to learn, no? Okay. So thank you so much for your responses. That pressure will be the main topic for today. Okay. So pressure in static fluids. But what is pressure? When we say pressure, or it is otherwise known as unit pressure, it is defined as the normal force per unit area exerted by a solid, liquid, or gas over a surface. Now, this pressure is synonymous to stress that we will encounter in our mechanics of deformable bodies. Now, when we say stress, mathematically, it's represented as sigma, and it's equal to force over area. Now, when we say pressure, the representation will just be different. It will be P. Okay? It will be P, and this is equal to force over area as well. So they are the same. Okay? So when we say stress, it is synonymous to pressure. Now, from the equation, force over area. Pressure is equal to these forces applied over a certain area, right? So we just have to take, we just have to determine the magnitude of the force and the surface area. In this case, so we have here a cylindrical uh, object, a cylindrical fluid rather. No? So we take the cross-sectional area of that fluid and we will arrive with pressure. Okay. Now, what's the unit of pressure? Well, if we have the force in the numerator, then in SI unit, it is Newton. And we have the area in the denominator, so we have m squared in SI unit. That's the unit of pressure. Newton over meter squared, or otherwise pascals. Okay, this is also equal to Pascal. For English, then we have pound per feet squared, or this can also be pound per inch squared. Okay, that's pressure. Now let's talk about Pascal's law. Yeah. Sino ba si Pascal? Well, si Pascal, he is a scientist and an engineer that lived sometime no in the past. So think he's born year 1618 and then died 17 something. Okay, so over the course of his life, he developed this Pascal's law. No? Now, what's this Pascal's law? Obviously, it is named after him. No? And it states that the intensity of the pressure acting at a point in a fluid at rest is the same in all directions. So, ibig sabihin, kung kukuha tayo dito ng portion, for example, ito yung fluid, yung forces or yung pressure dito na maia-apply, no? Or pressure applied to this portion or point in a fluid is equal in all direction. Okay? So kasi yung point na to, no? Yung point na to sa fluid, okay? Nag-a-act yung ibang nag-a-act yung katabi niyang fluid, right? So itong fluid na to, it acts at this point, also acts at this point, okay? But if we take a point, no, the intensity of the pressure acting in all direction is the same. Okay? So that's according to Pascal. Now, how can we prove this? How can we prove na yung pressure across all direction is the same? Well, we can consider this triangle. So this point in fluid, point of the fluid, this is the representation. Okay? So this represents the particle or the point of the fluid. Okay? triangular figure. Now this fluid will be acted upon by forces. So will be acted upon in this direction, and in this direction. Now we can represent the pressure that's acting in these three directions by three magnitudes. Okay, so for this direction, we can call this P sub Z, and then in this direction, we'll call this P sub Y, and then in this direction, we'll call this P sub X. So the law states that P sub X is equal to P sub Y is equal to P sub Z. No? Kasi sabi, intensity, the pressure acting on all sides is equal. Okay? So ipoprove natin yan. No? Ipoprove natin yan. So we will use the equilibrium equation. Summation of forces along X equals 0. So again, yung formula for pressure is equal to the force over the area. Okay? Now, summation of force with respect to X equal to 0. So this will be, the equation will be what? So we have P sub X. So this is the pressure acting on this direction times the area. Okay? So bakit P sub X times the area? It's because yung F sub X is equal to the pressure times the area. So cross to multiply to dito. Okay? So ito yun. Okay? The force acting on the horizontal. And then ano pa yung isa pang force na nag-a-act horizontally? Hindi yung PY, no? It is what? PZ. Because this PZ, we can reduce it into components. So we can have P sub Z sine theta, and then P sub Z cosine theta. Okay? So this is the horizontal component of P sub Z, and this is the Y component of P sub Z. So this P sub Z is going to the left. So this will become plus negative P sub Z, and then we have sine theta, and then times the area equals 0. Okay? Now we can expound the area. So this will become P sub X times the length. Okay? So let's call this A, B, C. AC is the length that we need. And then we will multiply it by the thickness. Okay? By the thickness. And that thickness is set to be 1. Okay? We will use unit 1. No? And then we add negative P sub Z sine theta. And then times area again. But what is the area? So we have the length of BC So this is BC. And again, we multiply it by 1. Okay? This one is the thickness. No? Thickness nung side na to. And this is equal to 0. Okay? Now, yung 1, pwede natin siyang alisin kasi basically, pag minultiply natin yung 1, ma-retain lang yung value ng isang number. No? So, this is P sub x AC minus P sub z BC sine theta is equal to 0. So basically, that's our first equation. Okay? Now we can look at the triangle. We can see that it is a right triangle. So if we take the sine theta, so sine theta is equal to what? Opposite over hypotenuse. So we have sine theta equals AC over BC. Now, if we cross multiply this BC to this side, it will become BC sine theta. Okay? So AC will become BC sine theta. Now, this AC, we can substitute it to this equation. So, ano yung magiging equation natin? It will become P sub X times BC sine theta minus P sub Z BC sine theta is equal to 0. Now, we can cancel out BC sine theta. So, ano matitira? Matitira is P sub X minus P sub Z equals 0. And if we transpose P sub Z on the other side, P sub X is equal to P sub Z. Now, we just prove that P sub X is equal to P sub Z. Any questions? Okay, simple enough, right? Now we just have to prove P sub y is equal to P sub z. Now, if this is the case, if P sub y is equal to P sub z, then we can say that P sub y is also equal to P sub x because P sub x is equal to P sub z. So, yan yung titingnan natin. No? So, we have to prove P sub y is equal to P sub z. So, I will delete this one. Okay. So, let's start. Now, let's have summation of forces along y naman equals to 0. So, what will be the equation? So, we have P sub y times area. Okay? This is A, this is B, this is C. And then, the other force that's along y also is P sub z cos theta. Okay? P sub z cos theta. So, this will become P sub y times area, pataas, so positive, and then plus negative because this P sub z cos theta is going downwards. And then we multiply the area. Okay? And this is equal to 0. Now, P sub y, okay, will be written again and then we will multiply the area, which is AB. Okay, the length of AB, and then times 1. This is the thickness of this side. Okay. And then plus negative P sub Z cos theta times the length of BC times the thickness again, which is 1. And this is equal to 0. This will become PY times AB minus P sub Z cosine theta BC equals 0. And then we can look at the triangle and determine cosine theta. So cosine theta is equal to adjacent over hypotenuse. So we have AB over BC. So if we cross multiply BC here, then the equation will be AB equals BC cosine theta. And then we can substitute this equation to this one. So making this P sub Y times BC cosine theta minus P sub Z cosine theta BC equals 0. Now we can cancel out BC cosine theta. Matitira na lang is PY minus PZ equals 0. If we transpose this P sub Z on the other side, it will become PY equals PZ. Okay? So we just proved that PY is equal to PZ and PZ is equal to PX. So they are just the same. Okay? Pressure acting at this side, z-axis, is equal to the pressure acting on the x-axis and pressure acting on the y-axis. Any questions? Okay, so that is Pascal's law. Now, let us discuss absolute and gauge pressure. So, dito tayo mag-focus sa figure. Okay. So, we can see here the absolute pressure. When we say absolute pressure, it's the intensity of pressure that is measured above the absolute zero pressure. Asan yung absolute zero pressure? Andito po yan. Okay? And yung absolute pressure, ma-measure natin depende sa taas niya. Relative to the absolute zero pressure. So, hindi pwedeng mag-negative yung absolute pressure. Okay? It's always positive. And then we have this atmospheric pressure. So when we say atmospheric pressure, it's the prevailing pressure in the air surrounding which decreases with increasing altitude. So as we increase the altitude, so let's say for example, we are climbing a mountain. Basically, the altitude increases. As the altitude increases, the pressure acting on us decreases. Okay? Because mas kokonti yung hangin na nag-a-act sa atin. Okay? So, mas konti yung atmospheric pressure. Now, meron tayong standard atmospheric pressure and it's equivalent to 101.325 kilopascal or 14.7 psi. So, ito yung para sa SI, ito yung para sa English, and then 760 millimeter mercury, okay, or 29.9 inches mercury, or 2,116 pounds per square foot, or 1 atmosphere. So, yan yung standard atmospheric pressure. Nasaan nakuha yon? Yung standard atmospheric pressure, that's the absolute pressure, okay, absolute pressure that is measured at the mean sea level. Okay, the mean sea level at the temperature of 15 degrees Celsius. And then we have the gauge pressure. So, ito yung relative pressure. No? Yan. It's the pressure that is measured above or below the atmospheric pressure. And it can be solved by getting the difference of the absolute pressure and the atmospheric pressure. Okay? So, magiging basis natin, add these numbers. So, given absolute pressure, minus lang natin yung atmospheric pressure, no? And we can get the gauge pressure. So, that's the relative pressure. Okay, measured above or below the atmospheric pressure. Okay. So, now let's go to static pressure variation in incompressible fluids. So, dito sa PowerPoint natin, medyo nakakahilo. But basically, what we want to get out from here is makuha kung paano kinukuha yung pressure at any point in a liquid. So, let's say, for example, meron tayong container at puno siya ng tubig. Paano natin malalaman yung pressure sa bottom? Paano natin malalaman yung pressure dito sa surface? Paano natin malalaman yung pressure dito sa point in between the surface and the bottom? So, that's the goal of this slide. Okay? So, let's focus on this figure. Let's say we have a strip or a section of fluid. Let's say, for example, in-isolate natin itong section na to, no? Dito sa fluid. Okay? So, napapalibutan siya ng tubig. So, ibig sabihin, meron pressure na i-apply yung katabi niyang tubig sa kanya. So, meron ditong pressure. Yan. Okay? Now, ang gusto nating malaman is paano natin makukuha yung pressure sa point na to. Okay? Sa point na to. So, we have 2 points. Actually, we have point 1 tsaka point 2. No? So, point 1 tsaka point 2. Now, paano natin malalaman yung pressure at point 2 relative to point 1? Okay? So, meron tayong length dyan. Meron tayong force. Okay, F1 and F2. So, ito yung pressure. No? Ito yung force, sorry. Ito yung force na nag-a-act dito sa point 2 And ito yung force na nag-a-act sa point 1. And then meron din tayo ditong weight. Okay, yan yung self-weight nung section na to ng fluid. And then we also have the height. Okay. So, we can use the equilibrium equation, summation of force along x-axis equals 0. But ano ba dito yung x-axis? Yung x-axis is ito. Okay? Ito yung x-axis pag ganyan. So, the equation will become f sub 1 plus w cosine theta. Okay? Kasi yung w natin, pababa. No? So, to get the x component of w, we'll have to multiply cosine theta. Okay? We'll have to multiply cosine theta. So, kaya naging f1 plus w cosine theta. And then, minus f sub 2. Kasi it's going towards this direction. So, opposite nung positive x-axis. O kaya, f sub 1 plus w cosine theta minus f sub 2. Remember, yung force natin equal siya sa pressure times area. Kasi pressure equals force over area, right? So, cross-multiply dito, ito magiging equation. So, therefore, pressure at point 1 times area yung magiging equation. Okay? So, from f sub 1, naging ganito. And then, so, we move to this w cos theta. Remember that unit weight is equal to weight over volume. Okay? So, therefore, weight is equal to unit weight times volume. Kaya, this has this, naglagay tayo dito ng unit weight. And then we multiply what? The volume. Eh, ano ba yung volume? Volume, in this case, is equal to the area times the length. Okay? Yung area natin dito is yung cross-sectional area nung strip na to. Okay? Cross-sectional area ng strip na yan times the length. So, yun yung volume. Okay? Kaya naging length times area. And then we add cos theta. Okay? From this one. And then we expound f sub 2. So again, just like f sub 1, it's equal to the pressure at point 2 times the area. Now, yung area natin dito can be cancelled because lahat sila merong area. So, pwede natin siyang tanggalin. And then the equation will become this one. So, pressure at point 1 plus the unit weight of the fluid times the height. So, when we say height, that's the vertical distance from point 1 to point 2. And then minus the pressure at point 2 equals 0. And rearranging this, we will come up with this equation. So, P sub 2 minus P sub 1 equals gamma times height. So, para pala makuha yung pressure, like let's say, for point 2, no? Pressure of point 2, it's equal to P sub 2 equals. So, transpose natin to sa kabila. P sub 1 plus gamma H. Okay? Now, this equation is very important because ito yung gagamitin natin to solve problems in fluid statics of incompressible fluids. Okay? Now, ito po yung equation, yan, para dito sa fluid na nasa gitna. Okay? Nasa gitna nung container. So, itong F sub 1 na to, submerged na siya. 'Di ba? Submerged na siya. As well as F sub 2. So, ito yung equation natin. Now, paano kung yung isang point is nasa surface? So, kumbaga, ito yung container. Ito yung container. Tapos, yung isang point, andito, sa surface. Ano yung magiging equation natin? Well, yung P sub 1 natin, basically, magiging ano? Pag equal siya sa anong value? 0. Okay? 0 siya. Bakit 0? It's because walang fluid na nasa taas niya. So basically, walang pressure. Okay? So we treat the air, no? We treat the air as having no pressure. Kaya 0. Kasi yung nasa taas na nito, air na eh. Di ba? Therefore, P sub 1 is equal to 0. So ano yung magiging equation natin? So, remember, P sub 2 equals P sub 1 plus gamma H. So, kung 0 to, edi magiging P sub 2 equals gamma H na lang. Okay? So, that's static pressure variation in incompressible fluids. Any questions po? Any questions? Okay lang ba? Okay pa ba kayo, guys? Masyado bang mabilis or what? Okay naman. Pag di na kayo okay, pwede nyo namang sabihin lang. So, uulitin natin kung di naintindihan. Okay naman. Sige. Okay. So, dito sa PowerPoint na to, ang nadagdag lang is itong figure. So, yung dalawang point natin has the same depth. Okay? It has the same depth. So, ano yung pressure nito? Yung pressure nito, since magka-level silang dalawa, is equal. Okay? So, equal yung pressure at point 1 sa point 2. Kasi magka-level sila. Okay? So, yung pressure natin, highly dependent siya on the height. So, kapag mas mababa yung depth nung point sa fluid, mas mataas yung pressure. Tama lang naman. Kasi, imagine meron kang container, tapos andito yung point mo, no? So, maraming tubig na mag-a-act dito sa point na to. Eh, compare mo yan dito sa point na to, so mas kokonti yung tubig na mag-a-act sa taas niya. So, it's highly dependent on the height. Okay? So, again, in summary, the equation to be remembered is this one. Okay? P sub 2 equals P sub 1 plus gamma H, wherein P sub 2 is the pressure of the point below. P sub 1 is the pressure of the point above. Gamma is the unit weight of the liquid. And H is the vertical distance between the 2 points. Okay. So, let's discuss pressure head. When we say pressure head, it's the height of a column of homogeneous fluid that will produce a given intensity of pressure gauge. So remember, P is equal to gamma H. Now, if we cross multiply gamma in the denominator, so it will become H equals P over gamma. So this H, ito yung pressure head. Okay? So, with that, let us solve this problem. Given a pressure of magnitude 50 kilopascals, find the pressure head of water with a unit weight of 9.81 kilonewton per meter cube and the pressure head of the mercury with a unit weight of 133 kilonewton per meter cube. Let me share my external cam. Okay. We are given 50 kilopascal of pressure as well as the unit weight of water and mercury. So that is 9.81 kilonewton meter cube and 133 kilonewton per meter cube respectively. Now, the required is the pressure head. And to solve for the pressure head, so we will use the equation H equals P over gamma. So this is equal to, so let's solve first for the pressure head of the water. Okay, so this is 50 Newton per meter squared. Oh, sorry, 50 kilonewton per meter squared over 9.81 kilonewton per meter cube. So the kilonewton will cancel out as well as the meter squared. The unit will be meter only. So what is the height of the pressure head? Is it 5.10 meters? Can you use your calculators? Okay. So 5.10 meters. Okay? So yan yung height nitong water that will produce a pressure of 50 kPa. Yan. 5.10. How about mercury? Again, it's pressure over unit weight. So we have 50 kilonewton per meter squared over 133 kilonewton per meter cube. Again, we cancel out kilonewton and meter squared. The H or pressure head is equal to 0.38, yes, thank you, meter. So if we will look at mercury, so yun yung height na makapagpo-produce ng 50 kPa. So sobrang liit lang, no? Sobrang liit in comparison to the water. Bakit? It's because yung mercury, diniscuss naman natin in the past lectures na mabigat. Okay, yung unit weight ng mercury is high. Okay, in comparison to the water. Kaya yung required H or yung required pressure head is just low. Okay? Because na-compensate na yung lack ng height sa bigat ng mercury. Okay, na makapag-produce siya ng 50 kPa. Okay? So that's how we compute pressure head. Okay. So let's answer 2 sample problems. So let's read this one. The underground storage tank used in a service station contains gasoline filled to the level 8. Determine the gauge pressure at each of the 5 identified points. Note that point B is located in the stem and point C is just below the tank. Okay, putol yung problem dito. So, let me just check kung ano yung given. So, given tayo ng mass density ng gasoline, 730 kilogram per meter cube. Yan. So, required tayong kunin yung gauge pressure at point A, point B, point C, point D, at point E. Okay. Now, again, what's the equation for doing so? That's P sub 2 equals P sub 1 plus gamma H. Also, we will use P equals gamma H. Yan. So, sinulit lang natin. Okay. So, for P sub A, what is the gauge pressure? Pressure at point A. Ano po yung gauge pressure natin? It is 0. Okay? It is 0 because there is no liquid above point A. Okay? What about point B? We apply this equation. Okay? So we have point B equals point A plus gamma H. Okay? So, P sub A is 0 and then plus what? 730 kilogram per meter cube times 9.81 meter per second squared. Okay, that's how we calculate the unit weight. Mass density times G. And then we multiply the height. So ano po yung height dito? Yung height is yung vertical distance between point A and point B. Kasi ginamit natin dito is pressure A. Okay? So dito tayo titingin, no? Pag kukunin natin yung height, titingnan natin yung distansya nitong dalawang points na to. So in this case, point B and point A. So ano yun? It is 1 meter. Yan. So we use 1 meter. Now what is pressure at point B? Okay, thank you, Paul. It's 7.16. Now what is the unit? This will be what? Newton per meter squared. Because magka-cancel yung meter, ito magiging meter squared, and then kilogram times meter per second squared is Newton. Yes, phi. It's also equal to 7.16 kPa. Yun. It's the answer for the pressure at point B. Now next, pressure is point C. Now since magkalapit lang naman sila with point B, we zoom in. No? Kalapit lang sila with point B. So basically, yung pressure dito sa point C is just the same. Okay? Wala naman tayong given ditong distance between B at C. So, yung pressure natin at C is equal sa 7.16 kPa din. Okay? So that's pressure at point C. Okay, next. Pressure at point D. So we can use this equation again. So we will just have to set this P sub 2 as P sub D and this P sub 1 as P sub A. Okay? So gamitin natin yung P sub A. So P sub D is equal to P sub A, which is equal to 0. And then plus 730 kilogram per meter squared times 9.81 meter per second squared times ano yung H? Okay, according to Andrea, it's 5. According to Paul, it's 1. Yes po, it's 1 meter plus 2 meters. Yun. Oh, 60 meters. So what is pressure at point D? Yes, it's 21.48 kPa. So, kinonvert na agad natin. No? Kasi makukuha dito, Newton per meter squared. Tapos, divide lang natin by 1,000. It will be equal to 21.48. Yan. No? That's the pressure at point D. Now, yung ginamit natin dito is yung pressure at A. What if sa iba tayo nag-refer? Okay, ibang point yung ginamit natin. So, tingnan nga natin kung same pa din yung makukuha nating sagot, 21.48 kPa. Paano kung ginamit natin yung P sub B? Okay? So, tingnan natin kung same. Dapat same sila ng sagot. So, P sub D equals P sub B plus gamma H. So, ano yung P sub B? P sub B is 7.16 Newton per meter squared. And then plus 730 times 9.81 times what? Ano yung H natin? If yung 2 points is D and B, ano po yung H? Okay, we have 2. So ano po yung pressure at D? Can you solve? Okay, it's equal to 14.33 kPa, which is not the same with D, P sub D that we computed using P sub A. Okay? So, hindi sila same. No. Bakit kaya? Kasi nakuha natin dito is 7.16. 7.16 kPa. This is just Pascal. Okay? This is just Pascal. Wait. Alam ko na. Alam ko na. Dito, kailangan kilonewton over meter cube yan. Okay? So, ito kPa to. Now, itong 7.16 dapat times 10 to the third power pa to. Yon. Thank you, Andrea and Alexander. Ito yung tama. Okay? 7.16 times 10 cube Newton per meter squared. Kasi yung 7.16 kilonewton per meter cube or meter squared converted na siya. Okay, kinonvert na natin yung nakuha natin dito na Newton per meter cube. So, dapat 7.16 times 10 cube Newton per meter squared. So, ano po yung magiging pressure at point B? Yun, 21.48 kPa. Yes, yes. So, thank you, Andrea and Alexander. So, kita nila yun, no? Very good. So, ang bottom line dito, okay, ang bottom line dito, pwede tayong gumamit ng kahit anong points. No? Ng kahit anong points above the point na kinukuhaan natin ng pressure. Given na alam natin yung pressure nung nasa taas. Okay? Kasi kung kinuha agad natin yung pressure at D at hindi pa natin alam yung pressure at B, syempre hindi natin pwedeng gamitin ito. So, ang gagamitin natin yung pressure at A. At if we know pressure at B, we can solve for pressure at D. Okay? Same lang din siya with pressure na nasa surface. Okay? That's how we determine the pressure. Now, meron pa tayong isa pang point dito. That is point E. So, since same lang naman si point D tsaka point E ng depth, same lang din siya ng pressure with D. Remember, kanina, we discussed na kapag same ng depth or height si 2 points, parehas lang sila ng pressure. So, yung pressure mo at point E is equal to 21.48 kPa as well. Okay? So, any questions po? So, ito yung sagot natin. Okay. So, let's proceed to the last number for today. Last problem. So, let's read the problem. The funnel is filled with oil and water to the levels shown. So, we can see here, this is the oil and this is the water. Determine the depth of oil that must be in the funnel so that the water remains at depth C. And the mercury level made H equals 0.8 meter. And then, naputol yung question. So, sabi, take the mass density of the oil to be 900 kg over meter cube. Density of water to be 1,000 kilogram per meter cube. And density of the mercury to be 13,550 kilogram per meter cube. use the equation P sub 2 equals P sub 1 plus gamma H. Now let's determine the pressure at different points. So here we have different fluids. Okay, we have different fluids. So we have oil, water, and then mercury. So let's determine what's the pressure at point B, wherein yung nasa taas is yung oil. So let's write the equation. P sub B is equal to P sub A, wherein P sub A is 0. Okay, because it is exposed in the air. There is no liquid above it. And then plus the unit weight of the oil times the height. So what is the height? Height is yung hinahanap natin. Yung h hat. Ito yung required. So ito yung equation. Next, let us write the equation for the pressure at C. We have P sub C. And this is equal to what? Pressure at B plus gamma ng water times the height. Now, what is the height? 0.4. Now, we can substitute P sub B to this. So, this will become P sub B equals P sub A plus gamma of oil H plus gamma of water times 0.4. And then we have pressure at point D. So pressure at point D, we can use pressure at point C. Okay? Because yung kasunod na liquid ni mercury is si water. No? So we can use P sub C. And then minus. Okay? Minus gamma of Hg times the height. So what is the height? Height is 0.2 plus H plus 0.4. Okay, so we get this one. So that's the height. And then we subtract H. Okay. Because andito yung pressure D. So if we have a manometer, ganito po yung magiging setup. Okay. So we take the height from the surface up to the point. Okay, in this case, point C. And then we subtract the height of point D from the surface. Ito na yung magiging equation natin. Now we can substitute pressure at C here. So this will become P sub D equals okay. So this will be the equation. Now we can substitute the values. So P sub A, again, pressure at A is 0 plus what? We have gamma H. So the density of the oil is 900. We need to multiply this by 9.81 to get the unit weight. And then times H plus 1,000. So that's the mass density of water times 9.81 to make that unit weight. And then times 0.4. And then minus. So what's the mass density of mercury? It's 13,550. Then we multiply 9.81 again to make it a unit weight. And then times what? So we can simplify this one. 0.2 plus 0.4 is 0.6 minus 0.8 is 0.2. This will become H minus 0.2. Okay. Now the equation will become this. And then we can solve for H. Okay. What's the value of PD here? The value of PD, since it is exposed, there is no liquid above it. It is 0. Okay. So 0 equals 900 times 9.81. 8,829 each. And then plus 1,000 times 9.81 times 0.4. 3924. And then minus 13,550 times 9.81. It's equal to 132,925.5 each. And then plus 13,550 times 9.81 times 0.2. So it's equal to 26,585.1. Now what is H? It's equal to 0.25 meter. So this height is equal to 0.25. Any questions? Okay. So, paano daw po nakuha yung 0.25? So, from this equation, ayan, sana kita natin. From this equation, so yung variable lang po natin dito is yung h hat. Okay? Yung h hat. So, since yung pressure natin at D is 0, ayan, 0 to because air na yung nasa taas ni point D. And then, sinimplify natin yung equation. Okay, so this 900 times 9.81, it becomes this. This becomes this. This, it becomes this. And then, this becomes this. And then, tinranspose lang natin yung 26,000 tsaka 8,924 on the other side. Tapos, sinubtract natin yung 1T2 o kinuha natin yung difference ng 1T2925.5 tsaka 8,829 and then saka natin dinivide ito, yung difference nila dito sa total nitong dalawa. Okay, so it's just algebra, no? Pag-transpose. And then saka natin nakuha yung 0.25. Okay. So, thank you for that question. So, any other question or concern? Okay. So, let's publish your assignment. So, 2.1 for fluid statics. So, it's composed of 4 problems that you can answer until April 5. Okay? So, it's all about the topics that we discussed earlier. Sir, ano po yung wetting angle sa assignment 1.2? So, sige, tingnan natin. Yung wetting angle dito is yung theta. Kurt. Sir, may break po ba? Actually, tapos na tayo. Mark. Actually, yan, nakapublish na siya. Nasa canvas na natin yung PowerPoint. So yung wetting angle, Kurt, yan yung theta. So let me just Sir, pengen din po ng mga solutions. Okay, I'll send the solutions at our group chat. So yung sa surface tension, given kasi dyan yung, wait, specific gravity, and then diameter, surface tension, tsaka capillary depression. So, actually, given na lahat ng kailangan natin, except sa unit weight. Okay? So, you just have to compute for the unit weight. And then, yun, yung sinabi mo, arc cosine to get the wetting angle. Okay na, Kurt? Okay, sige. So, any other questions? If none, you may leave the conference. I'll see you all on Thursday, 10:30 a.m. Thank you for listening and have a great day, everyone.